In this video, we're going to look at solving problem 78 in our textbook, which asks us to prove that the supremum of a point set is unique if it exists. So to get started, we are going to let S be a set where both P1 and P2 are supremum. So they are suprema for set S. Now what this basically means is that both P1 and P2 satisfy the definition of supremum for the set S. So in other words, what I know is I know that P1 is an upper bound for set S, and I also know that P1 is smaller than or equal to any upper bound for the set. So P1 is less than or equal to U for all upper bounds U. And I also know that P2 satisfies the definition of supremum, so I know that P2 is an upper bound for set S, and I know that P2 is less than or equal to U for all upper bounds U of set S. Now I'm actually going to box in two things because they're going to be relevant. I'm going to call this particular boxed in clause star, and we're going to call this one double star. Now both star and double star involve universally quantified statements. You can put in any upper bound that you want to into these two statements. And what I want to notice is that P1 is an upper bound for S, and so I can put P1 in for that U in double star. In other words, since P1 is an upper bound for set S, double star tells me that P2 is less than or equal to P1. But I can also look at the same kind of thing for this statement. P2 is an upper bound for S, and I can plop that into the universally quantified statement for P1, star up here. And when I do, I can say that since P2 is an upper bound for set S, the starred statement implies that P1 is less than or equal to P2. And now what I'm going to do is I'm going to look at these two things together. These two things together say that P1 and P2 are exactly the same thing, and that lets me say that the sup of a set is unique if it exists. Not all sets have sups, so we do have to have a sup before this can make sense. Now it turns out that the proof that infimums are unique work in exactly the same way. And so what I'm going to do is I'm simply going to write that thing down as a note. So the proof that if the infimum of a set exists, then the infimum of a set is unique, works the same way. And that's it for this video.